Semiconductors, or chips, are the unseen engines of modern technology. They are the fundamental building blocks that enable the functionality of countless devices we use daily. These silicon marvels, etched with billions of transistors, are the backbone of our digital age. Each transistor acts as a tiny switch, controlling the flow of electricity and enabling complex computations. From smartphones to powerful computers, chips manage electricity, perform rapid calculations, and store vital information. They are essential for the seamless operation of software applications and the internet. Beyond consumer electronics, chips are crucial in automotive, healthcare, and AI industries. In cars, they control everything from engine performance to safety features. In healthcare, they power diagnostic equipment and wearable devices. In AI, they enable machine learning and data processing. Control over chip manufacturing equates to influence over future technology and economic power. Countries that lead in chip production can drive innovation and maintain a competitive edge in the global market. The military also relies on advanced chips for defense and communication systems. These chips are integral to the operation of radar, navigation, and secure communication networks. The global chip supply chain is a national security matter, sparking intense competition. Disruptions in this supply chain can have far-reaching consequences, affecting everything from consumer electronics to critical infrastructure. Understanding chips is key to grasping 21st century dynamics. As we move towards a more connected and automated world, the role of chips will only become more significant. As technology advances, demand for powerful, efficient chips will grow. Innovations in chip design and manufacturing will drive the next wave of technological breakthroughs. The quest for chip control shapes international relations and future progress. Nations are investing heavily in research and development to secure their place in the semiconductor industry, recognizing its strategic importance. China, a manufacturing giant, faces a chip dependency issue. This dependency has been growing over the years as the demand for advanced electronics surges globally. Despite leading in electronics production, it imports over 80% of advanced semiconductors. These imports are crucial for the production of smartphones, computers, and other high-tech devices. This reliance on foreign chips is a critical vulnerability. Any disruption in the supply chain can have significant repercussions on the country's tech industry. China aims for self-sufficiency to reduce geopolitical risks. The government has been investing heavily in domestic semiconductor research and development. The gap between consumption and production is a national concern. Bridging this gap is essential for maintaining economic stability and technological leadership. Disruptions in the global chip supply chain threaten China's electronics industry. The COVID-19 pandemic has further highlighted the fragility of these supply chains. The Made in China 2025 plan hinges on overcoming this semiconductor shortfall. This ambitious plan aims to make China a global leader in high-tech manufacturing. High-end chips for AI and 5G remain out of reach domestically. These technologies are critical for the future of smart cities and advanced communication networks. China's quest for chip independence is a cornerstone of its national strategy. Achieving this goal will require overcoming significant technical and economic challenges. The U.S. views China's tech rise as a strategic challenge, imposing export controls to maintain its technological edge and national security. Sanctions target Chinese tech giants like Huawei and SMIC, slowing their progress and limiting their ability to compete globally. Key equipment like EUV lithography machines, essential for advanced chip production, is blocked, hindering China's chip-making capabilities and innovation. Without access to advanced chips, Chinese firms lag behind global competitors, affecting their market share and technological advancements. Sanctions force China to rethink supply chains and invest heavily in domestic alternatives, aiming to build a self-sufficient semiconductor industry. Restrictions also impact access to essential design software, which is crucial for developing cutting-edge semiconductor technologies. The U.S. strategy curtails China's semiconductor development, aiming to prevent it from becoming a dominant player in the global tech industry. These actions push China to accelerate self-reliance efforts, investing in research and development to overcome these technological barriers. China is urgently developing its own chip-making capabilities to reduce reliance on foreign technology and secure its tech future. SMIC leads the charge, pushing domestic technology despite sanctions, aiming to become a global leader in semiconductor manufacturing. Chinese firms are creating alternatives to foreign chip-making equipment, investing heavily in research and development to innovate and compete. Developing domestic lithography machines is a major challenge, requiring precision engineering and significant technological breakthroughs. SME works on DUV systems, aiming for EUV alternatives which are crucial for producing the most advanced chips. SMIC's 7nm chip for Huawei shows progress, but faces yield issues, highlighting the complexities of advanced chip production. China's determination is clear, but the road to chip independence is long, requiring sustained effort and overcoming numerous technological hurdles. China invests heavily in semiconductor self-sufficiency, aiming to reduce reliance on foreign technology and bolster its own tech industry. The National Integrated Circuit Industry Investment Fund, also known as the Big Fund, leads this effort, providing crucial financial support to key projects. Billions are channeled into chip design, manufacturing, and workforce development, with a focus on creating a robust and skilled workforce to drive innovation. In 2023, China planned over $40 billion in new chip investments, marking a significant increase from previous years and highlighting its commitment to the sector. The strategy includes tax breaks and incentives for private companies, encouraging domestic firms to expand their capabilities and compete globally. Concerns about investment efficiency and international scrutiny persist, with analysts questioning the long-term sustainability of such massive financial outlays. Despite challenges, China's financial commitment reshapes the global chip landscape, positioning itself as a formidable player in the semiconductor industry. China's semiconductor efforts show both significant progress and numerous challenges. The nation is investing heavily in its semiconductor industry to reduce reliance on foreign technology. Huawei's 5G phone, featuring a domestically produced 7nm chip, marks a major technological breakthrough. This achievement highlights China's growing capabilities in advanced chip manufacturing. Chinese AI chip companies are emerging as strong local alternatives to global giants, focusing on developing specialized chips for artificial intelligence applications. These companies are gaining traction in both domestic and international markets. YMTC has made significant advances in NAND flash memory technology despite facing trade restrictions. Their progress is crucial for China's goal of achieving self-sufficiency in memory chip production. SMIC's production of 7nm chips faces challenges related to yield and cost. These issues highlight the complexities involved in scaling up advanced semiconductor manufacturing. Scaling up production to meet global demand remains a critical hurdle for China's semiconductor industry. Efficient mass production is essential for competing on the world stage. Technical barriers persist, particularly in accessing advanced lithography equipment. This technology is vital for producing cutting-edge chips, and remains a significant challenge for Chinese manufacturers. Dependence on foreign design software such as electronic design automation (EDA) tools is a vulnerability for China's chip industry. Developing indigenous software solutions is a priority to mitigate this risk. The shortage of experienced specialists is a significant bottleneck. China is investing in education and training programs to build a skilled workforce capable of driving the semiconductor industry forward. Replicating the Western semiconductor ecosystem is a monumental task. China must develop a comprehensive and integrated supply chain to achieve its ambitious goals in the semiconductor sector. China lags behind global chip leaders like TSMC and Samsung, who have established themselves as the front-runners in the semiconductor industry. These companies lead in advanced chip fabrication, using cutting-edge technology and maintaining a significant edge in research and development. SMIC's 7nm process is 2 generations behind, highlighting the challenges China faces in closing the technological gap. TSMC and Samsung use EUV lithography for better yields and cost-effectiveness, a technology that remains out of reach for many Chinese manufacturers. The technological gap includes equipment, materials, and intellectual property, with Chinese firms struggling to secure the necessary patents and high-quality raw materials. China's efforts to catch up face a moving target as leaders advance, making it increasingly difficult to bridge the gap. Achieving parity at the leading edge remains a distant prospect, with TSMC and Samsung already working on 3nm and beyond. Semiconductor dominance is a geopolitical issue with global implications. The race to control chip production is not just about economic power, but also about military and technological superiority. Chips are strategic assets, crucial for national security and technological leadership. They are the backbone of modern military systems, artificial intelligence, and advanced computing. The US aims to slow China's progress by restricting access to advanced technology. These measures include export controls and sanctions targeting Chinese tech firms. Export controls impact commercial and military tech development. They limit China's ability to procure the latest chip-making equipment and materials, hindering its technological advancements. China views these restrictions as attempts to stifle its growth. The country is investing heavily in its semiconductor industry to reduce dependency on foreign technology. Achieving chip self-sufficiency is a matter of national sovereignty for China. The government has launched initiatives to boost domestic chip production and innovation. The chip war influences global power dynamics and technology standards. Nations are vying for control over semiconductor supply chains, which will shape the future of global technology leadership. China's path to semiconductor self-sufficiency is a long journey, marked by significant investments and strategic planning. Focus will be on scaling 7-nanometer production and improving yields, which requires cutting-edge technology and substantial R&D efforts. Recruiting skilled engineers and investing in education are key strategies, as China aims to build a robust talent pipeline for the future. Building a resilient local supply chain is crucial to mitigate external dependencies and ensure steady production. China may explore alternative technologies like GaN and SiC to diversify its semiconductor capabilities and stay ahead in innovation. Chip independence is vital for China's broader ambitions, including national security and technological leadership. The technological gap remains wide, but China is a formidable force, continuously narrowing this divide through relentless efforts. Full self-sufficiency is distant, but China will reshape the global industry. The chip chase continues, driven by ambition and innovation. China needs to focus on several key areas to succeed in the chip war. The semiconductor industry is highly competitive, and staying ahead requires a multifaceted approach. Firstly, they must invest heavily in research and development to innovate and create cutting-edge technologies. This includes not only funding but also fostering an environment that encourages creativity and breakthrough discoveries. Secondly, building a robust supply chain that is less dependent on foreign entities is crucial. This involves developing domestic capabilities in raw materials, manufacturing, and logistics to ensure a seamless production process. Thirdly, fostering talent and education in semiconductor technology will ensure a steady stream of skilled professionals. Educational institutions need to collaborate with industry leaders to provide relevant training and hands-on experience. Lastly, forming strategic alliances and partnerships can help China gain access to critical technologies and markets. These collaborations can also facilitate knowledge transfer and open up new opportunities for innovation. By addressing these areas, China can enhance its position in the global semiconductor industry and work towards achieving greater technological independence. This strategic focus will be essential in navigating the complexities of the global market. The road ahead is challenging, but with a strategic focus and persistent efforts, China has the potential to become a dominant player in the semiconductor landscape. Continuous improvement and adaptation will be key to their long-term success. As China ramps up its efforts to dominate the semiconductor industry, it is investing billions of dollars into research and development, aiming to reduce its reliance on foreign technology and become self-sufficient in chip production. In response, the USA is planning to stop them by implementing strict export controls on semiconductor technologies and equipment, which are crucial for the production of advanced chips. These controls are part of a broader strategy to maintain technological superiority. These measures are designed to limit China's access to the cutting-edge tools and knowledge needed for advanced chip-making, effectively slowing down their progress and maintaining a competitive edge for the USA and its allies. Furthermore, the USA is forming alliances with other countries, including Japan, South Korea, and European nations, to create a united front against China's technological advancements. These alliances are crucial for sharing intelligence and coordinating policies. By collaborating with allies, the USA aims to create a robust global network that can counterbalance China's growing influence in the tech world. This network is expected to foster innovation and secure supply chains. In addition to these defensive strategies, the USA is also focusing on offensive measures to strengthen its own semiconductor capabilities. The USA is investing heavily in its own semiconductor industry, with significant funding directed towards building new manufacturing plants and supporting domestic companies. By boosting domestic chip production and innovation, the USA seeks to reduce its dependency on Chinese chips and secure its place as a leader in the semiconductor sector. This includes initiatives to train a skilled workforce and enhance research facilities. Other pressure tactics include imposing sanctions on Chinese companies, which restrict their ability to access international markets and collaborate with foreign firms. These sanctions are designed to cripple the operations of key Chinese tech firms, limiting their ability to compete globally and stifling their growth. The USA is also targeting the supply chain by restricting access to critical raw materials needed for chip manufacturing, such as rare earth elements and specialized chemicals. These combined efforts highlight the intense geopolitical struggle for semiconductor supremacy, with both nations vying for control over the future of technology. As both nations push forward with their respective strategies, the competition is expected to intensify, leading to significant shifts in the global tech landscape. The global semiconductor landscape is set for a dramatic and high-stakes showdown, with far-reaching implications for the tech industry and global economy. As the global semiconductor race intensifies, one critical question remains: can China develop EUV machines for their chips? This question is pivotal as it could determine the future balance of power in the tech world. Extreme ultraviolet EUV lithography machines are the crown jewels of advanced chip manufacturing, enabling the production of the smallest and most powerful semiconductors. These machines use light with extremely short wavelengths to etch intricate patterns onto silicon wafers, a process essential for creating cutting-edge chips. Currently, the leaders in EUV technology are concentrated in the hands of a few, with ASML from the Netherlands standing at the forefront. ASML's dominance is due to its decades of research, substantial investment, and a unique ability to integrate various complex technologies into a single machine. Developing these machines is no small feat. It requires a multidisciplinary approach, combining expertise in optics, materials science, and precision engineering, along with a robust supply chain for specialized components. The costs involved are astronomical, with a single EUV machine priced at over $150 million. This high cost is due to the intricate and precise nature of the components, as well as the extensive R&D required to perfect the technology. Additionally, the technology is incredibly complex, requiring years of research and development, along with unparalleled precision in engineering and manufacturing. Each machine must be meticulously assembled and tested to ensure it meets the stringent requirements of semiconductor production. China faces significant challenges in this arena. The country must build a foundation of technical expertise and infrastructure, which involves training a new generation of engineers and scientists. The country must overcome not only the technological hurdles, but also the geopolitical constraints imposed by export controls and international sanctions. These restrictions limit China's access to critical components and technologies needed for EUV development. However, the opportunities for China are equally enormous. Successfully developing EUV technology would not only boost its semiconductor industry, but also enhance its overall technological capabilities, fostering innovation across various sectors. Success in developing EUV machines would catapult the nation into the upper echelons of the semiconductor industry, reducing its dependency on foreign technology and securing its position as a global tech leader. This achievement would also have significant economic and strategic implications. Industry experts and analysts provide a mixed outlook on China's prospects. While some are optimistic about China's potential, others remain skeptical due to the immense challenges involved. Some believe that with sufficient investment and talent, China could develop its own EUV technology within a decade. The country's commitment to funding research and development, along with its growing pool of skilled engineers, supports this optimistic view. Others argue that the barriers are too steep, and that China will continue to lag behind the current leaders. They point to the existing technological gap and the difficulties in catching up with decades of accumulated expertise and innovation. In summary, the quest for EUV technology represents both a monumental challenge and a transformative opportunity for China. The outcome of this endeavor could redefine the global semiconductor industry and shift the balance of technological power. As the nation pours resources into this endeavor, the world watches closely, aware that the outcome could reshape the global semiconductor landscape for years to come. The stakes are high and the implications are profound, making this a critical juncture in the tech race. As China strives to enhance its semiconductor capabilities, The nation is actively seeking allies and partners to bolster its chip manufacturing efforts. This strategic move is crucial for China to reduce its dependency on foreign technology and to build a more resilient supply chain. Despite geopolitical tensions, several countries and companies could play pivotal roles in China's semiconductor ambitions. These partnerships could help China gain access to cutting-edge technologies and expertise that are currently beyond its reach. First, let's look at South Korea. The country is not only a technological powerhouse but also a key player in the global semiconductor market. Home to tech giants like Samsung and SK Hynix, South Korea possesses advanced semiconductor manufacturing technology. These companies have a long history of innovation and could provide China with valuable insights and technical know-how. While political dynamics with the United States pose challenges, economic opportunities could drive selective collaboration, especially in areas not restricted by international sanctions. Moving to Taiwan, the island is a critical player in the semiconductor industry. The island is home to TSMC, the world's leading semiconductor foundry. TSMC's advanced manufacturing capabilities are unmatched, making it a valuable potential partner for China. Despite the complex political relationship between China and Taiwan, there have been instances of technology transfer and collaboration between Taiwanese firms and Chinese companies. These collaborations have often been driven by mutual economic benefits. However, this partnership remains delicate and politically sensitive. In Europe, Germany stands out due to its robust engineering expertise and strong industrial base. The country has a long history of industrial innovation and could offer China valuable technological insights. Companies like Infineon Technologies could offer valuable insights and technology partnerships. Infineon is a leader in semiconductor solutions and could help China improve its manufacturing processes. Additionally, European nations may seek to balance their economic interests with strategic autonomy, creating windows for collaboration. This balance could lead to mutually beneficial partnerships in the semiconductor sector. Japan, another semiconductor powerhouse, also presents potential opportunities. Japan's semiconductor industry is known for its innovation and high-quality manufacturing standards. Companies like Sony and Renesas have advanced capabilities in semiconductor design and manufacturing. These companies could provide China with the advanced technologies needed to compete globally. Historically, Japan and China have engaged in technology exchanges, and despite current geopolitical tensions, economic pragmatism might pave the way for future cooperation. Russia, though not a leader in semiconductor technology, has shown interest in collaborating with China to counterbalance Western technological dominance. Russia, though not a leader in semiconductor technology, has shown interest in collaborating with China to counterbalance Western technological dominance. This partnership could involve sharing research, development resources, and circumventing certain export controls. On the corporate front, China's tech giants like Huawei and SMIC are forging ahead with partnerships and acquisitions to enhance their semiconductor capabilities. These companies are investing heavily in research and development to close the technology gap with their global competitors. Collaborations with global companies, even under the radar, could provide critical technology transfers and expertise. These partnerships are essential for China to achieve its goal of semiconductor self-sufficiency. While geopolitical challenges persist, China has multiple potential allies and partners in its quest for semiconductor self-sufficiency. Each partnership brings unique advantages and complexities, and navigating these relationships will be crucial for China's success in the global chip race. The future of China's semiconductor industry will depend on its ability to effectively collaborate with these international partners. As China continues its ambitious quest to become a global leader in semiconductor manufacturing, it has faced numerous challenges and setbacks. The country's determination to reduce its dependency on foreign technology has driven massive investments and policy initiatives aimed at bolstering its semiconductor capabilities. These obstacles span technical difficulties, supply chain issues, and geopolitical hurdles, each contributing to a complex and often turbulent journey. The global nature of the semiconductor industry means that any disruption in one part of the supply chain can have far-reaching consequences. One of the most significant technical challenges has been mastering the intricacies of advanced chip manufacturing. This involves not only the development of cutting-edge technology, but also the ability to scale production efficiently and maintain high yield rates. Developing cutting-edge chips requires precision engineering, state-of-the-art equipment, and highly specialized expertise. The complexity of the processes involved means that even minor errors can lead to significant setbacks. Despite considerable investments, Chinese companies have struggled to achieve the same level of technological sophistication as established leaders like TSMC and Intel. These companies have decades of experience and a well-established infrastructure that gives them a competitive edge. For instance, attempts to produce chips at the 7 nanometers and 5 nanometers nodes have often fallen short of the desired yield rates, leading to delays and increased costs. Achieving these advanced nodes requires overcoming significant technical barriers and ensuring consistent quality. Supply chain issues have also posed a considerable barrier. The semiconductor industry is highly interdependent, with various stages of production relying on a seamless flow of materials and components. The semiconductor industry relies on a global network of suppliers for materials, equipment, and software. Any disruption in this network can lead to significant delays and increased costs, affecting the entire production process. China's efforts to localize its supply chain have been met with mixed results. While some progress has been made, the country still faces significant challenges in achieving self-sufficiency in critical areas. The country has faced shortages of critical components, such as photolithography machines, which are essential for advanced chip production. These machines are highly specialized and difficult to produce, making them a bottleneck in the supply chain. These shortages have been exacerbated by international export controls restricting China's access to key technologies. These controls are often driven by geopolitical considerations and can have a significant impact on China's semiconductor ambitions. Geopolitical obstacles have further complicated China's semiconductor ambitions. The global competition for technological supremacy has led to increased tensions and trade restrictions. The United States in particular has implemented a series of technological blockades aimed at curbing China's progress. These measures are part of a broader strategy to maintain technological leadership and protect national security interests. These measures include export bans on advanced semiconductor equipment and restrictions on Chinese firms like Huawei. Such actions have forced Chinese companies to seek alternative sources and develop indigenous technologies. As a result, Chinese companies have found themselves cut off from vital technology and expertise, forcing them to seek alternative solutions. This has led to increased efforts to innovate and develop homegrown technologies. Specific incidents highlight these challenges. The semiconductor industry is fraught with examples of ambitious projects that have faced significant hurdles. In 2020, Semiconductor Manufacturing International Corporation, SMIC, China's leading chipmaker, faced sanctions from the US government, which severely limited its ability to procure advanced manufacturing equipment. This has had a profound impact on the company's operations and its ability to compete globally. This disruption not only delayed SMIC's production plans but also sent ripples through China's broader tech industry, emphasizing the vulnerability of relying on foreign technology. The sanctions have forced Chinese companies to rethink their strategies and focus on building more resilient supply chains. Another notable example is the collapse of Wuhan Hongshin Semiconductor Manufacturing Company, HSMC. The company's failure has been a significant setback for China's semiconductor ambitions. Despite grand plans and significant financial backing, HSMC failed to deliver on its promises due to mismanagement, technical challenges, and funding issues. This has highlighted the importance of effective project management and the need for a skilled workforce. The project's failure underscored the difficulties of scaling up semiconductor manufacturing without the necessary expertise and infrastructure. Building a successful semiconductor industry requires not just investment, but also a strong foundation of knowledge and experience. These setbacks have provided valuable lessons for China. The country has learned the importance of building a robust and self-reliant semiconductor ecosystem. First, the importance of building a robust and self-reliant semiconductor ecosystem cannot be overstated. This involves not only developing local capabilities but also fostering a culture of innovation and collaboration. While international partnerships are beneficial, over-reliance on foreign technology exposes vulnerabilities. Diversifying sources and developing indigenous technologies are crucial for long-term success. Second, the need for sustained investment in research and development is crucial. Continuous innovation is essential to keep pace with the rapid advancements in semiconductor technology. Achieving technological breakthroughs requires not just funding but also a long-term commitment to innovation and talent development. Building a skilled workforce and fostering a culture of continuous learning are key to sustaining growth. In conclusion, China's journey in semiconductor manufacturing has been fraught with challenges and failures. However, these experiences have also provided valuable insights and lessons that can guide future efforts. However, these experiences have also offered critical insights and lessons. Learning from these setbacks is essential for building a more resilient and competitive semiconductor industry. As China continues to navigate the complex landscape of global semiconductor competition, learning from past mistakes will be essential for future success. The country's ability to adapt and innovate will determine its place in the global semiconductor industry.